All right, let's get the party on the road. So, brief overview. I'm going to give you the skills, at least the functionality to complete this lab. I'm going to talk kind of slow so that I can give you details when needed. Okay, so we're going to do our create a R Markdown file, press green plus, R Markdown. You should not have to create a new project. Please do not create a new project. Lab for pre-work. So this is not the answers for lab 4. This is the pre-work that will give you the skills to be able to do the work for lab 4. Okay, that's fair. We're going to do this, erase that. I'm going to erase it because I don't want to explain this to you. I'll erase this. Create a new R chunk. Okay, you can easily have press the green plus and then this button here. I'm going to do library tidyverse, and then we need to install a package called car, and that package contains the function to calculate the VIF of a multiple linear regression model. And so I think you should just say, you can say no, I think that should be fine. It's installing. There you go, you can do it. Good job. Got it. And so I'm actually going to do it differently than the notes. I'm actually going to keep it here as car. Okay, and then I'm just going to run this. Boom. Then there we go. So when it comes to the actual lab, you don't have to run StatCalPoly package this time. We are going to use some default data sets within R. So what that means is that if we wanted to learn more about the data sets, we can actually use the help function. So the first data set that we're going to look at is called Swiss. VIEW Swiss lowercase. Okay. And so I'm typing it in the console because I don't necessarily need this piece of code later. And so that's why I did that. Okay, and so here are the provinces within a particular country. Oh, Switzerland. And then here's some variables that was recorded within each of the provinces. If you do help Swiss, we don't necessarily have to help them, but this is going to give us help on the data set. Haha. You get background information about this data set, okay, which is cool. Which I'm pretty sure I provided within the question already, but yeah. Alright, so that's that. The next thing that we're going to do is actually jump. I'm going to do some little extra. I'm going to actually visualize. We're going to take our Swiss data set. We're going to pipe it. Okay, I just want to do it just so you all can see. Pipe it, and then the variables that we're going to consider is fertility, Catholic, and infant mortality rate, and all these variables are percentages. And we're just going to see how they're associated with one another. So we do this, and this is not actually a part of the lab, but you might be interested in learning more than what's required of you. Okay, I need infant mortality. It's kind of sad. Copy Catholic. Okay. And copy, and then last but not least, fertility. Okay. And the last thing we have to do here is just plot. I don't like using this function. If you ever take my Data Science Academy, you'll see that we don't use things that are this simple, but here we go. Okay, so wow, this is interesting. This makes sense because being Catholic is not necessarily either a lot of people are Catholic, a lot of people in the province are Catholic, the percentage wise, or nobody's Catholic. Yikes. You can see that the split in infant mortality. If I had it my way, I probably wouldn't have used the Catholic variable. But you can see with infant mortality and fertility, there's a positive association. Does that make sense? the more you have babies. As you have more if you have more deaths, you have more babies. Or the opposite, as you have more babies, you have more child. Yeah, that makes sense. That makes sense. That should be, it's a positive association. That makes a lot of sense. Okay. Let's go to what you're actually looking for. I'm gonna do a little bit of a copy and paste so I can speed up this video a little bit. This is what you're looking for. Okay, you need to run this, but then you need to add another variable here for the actual lab. So we run this and we get a regression output. Yay! Okay, so you should know where the regression coefficients are, the p-values, the standard deviation residuals, the r adjusted r squared, and that statistic. That's good. What we can then do is determine if there's an association, or at least there's some multicollinearity present within our data. So if you do VIF model 1, you get the VIF as accordingly. And so what's interesting here is that the code, I'm not going to explain more about the code, but there's the two VIF scores are the same. I think we went over this in class, but it would be to your benefit to think why that is the case. So that's that. So moving into categorical data analysis. So what we're going to do here, what's needed for the lab, is just for you to summarize the data and then do the chi-square test. But you know what? I'm actually going to take some time to visualize this data, just for funsies, even though it's not required. Okay, so this is the data set, UCB admissions, and come to find out, this data set's like real. This is a real data set. And so what we can do, I may even do a pause because I don't know the code off the top of my head, but I know it's ggplot. I'm going to look at both variables. I'm going to just AES X is equal to, let's look at department. And then Y is equal to frequency plus geom bar, and then I'm going to say stat is equal to identity. Take my data science academy class. You'll learn what all these things mean, at least for the most part. And then theme BW. Okay, and then it should do something. Yay, made it. Okay, so you see the bar plot. So which department has the most students? You can you could have kind of seen within that data, but at least you can see it here, right? You have A between A and C. The least is between B and E. I think it's B. Okay, so at least you can see a visualization. We can see more of the categories, but that's for a different class. I mean, as in gender and the other variable. It's slipping my mind. Gender and admissions. Okay, so you could make it a more complicated plot. And so the primary purpose is to see if these variables, these categorical variables, are associated with one another. And come to find out, what's very, very interesting is that the actual observational unit is a student. Though this data is in its aggregate form, a summary, but still, the actual observational unit is a student. We're measuring if they're admitted or not, their gender, and the department they were applying to. So then what we're going to do now is summarize the information, but only look at gender. Again, we're doing this for the chi-square goodness of fit test, but chi-square goodness of fit test should be used only when you have a categorical variable. But I'm going to do it for a categorical binary because I want you to do it for when the data is actually categorical. So you're going to change gender into the variable that's asked of you in the question. Please read carefully. If you go to sum_df, it gives you the count for gender and for male and female. Great. Fantastic. Okay, so this gives you the summary. That's fantastic. So what you can then do, and at the same rate, you can actually use that information to figure out the expected count. So if I give you said expected values, okay, you would take the sum of those two values. You take the sum of these two values and multiply by the percent that you expect. right? So if you had a percent that you expect 35% are male, you're going to add these two values and multiply by 0.35. There are faster ways of doing things, but this is not a programming class, so I'm not going to teach it. And so this is us doing the chi-square goodness of fit test where we expect 35% male, 65% female, and we would reject that claim. And our p-value is 2.2 times 10 to the negative 16. Again, this is chi-square goodness of fit test. Okay. The next thing we're going to do is an overview of the chi-square test of independence. Okay, so I'm going to summarize the information, but I'm going to summarize it in the sense of the two categorical variables that I'm looking at, gender and department. So here I'm trying to see if these two variables are associated or not. Okay, the null hypothesis is that they're independent. The alternative is that they're dependent. And so then we'll just run this. That summarized stuff you can just ignore. Okay. And so here is our table. This is our summarization. So here in your version is going to be a little bit easier. I think it's department, it's gender versus admission. You have to turn that into a contingency table to then be able to find what's the expected females admitted. So you can turn it into a contingency table, or if you have a better understanding of it, what you can do is just find the total number of females times the total number of admitted divided by the sample size. So you wouldn't have to you could bypass the contingency table. Okay, and so this is, you can turn this into a contingency table as well, but that's neither here nor there. Okay, so in order for us to perform the chi-square test of independence, a little bit more work. Again, right now I'm doing a little bit of a copy and paste game, and the notes are already there, so you can copy paste as well. But we use this xtabs function, and you write it in a very interesting format, count, okay, and then you just run this. So when you're watching this video, if I told you if you're watching it to the end, which I appreciate, and then I'm most likely going to tell you to watch the video, just change the variables based on the question, and utilize this view tab to figure out what the variable names are. I had a couple students come to me during learning hours, and I was able to help. But then if we look at these actual tabs, we'll figure out what to do with the analysis a little bit faster. That's all, folks.